how are we doing today? Good to hear Savannah and Caitlin and Abigail and Jamarcus. We went over Homework 5 Part 1 during class last time. We did the whole homework during class. Is there a specific one you're wondering about, Jamarcus? Woo! Disappear here. Come right back. Woo! I have 2 quick questions. Ask away. Yep, Caitlin's got it right there. We can do it. We can do Part 2 also right now. What questions do you have? Ask those questions in the chat at any time. Maybe we'll do Homework Part 2. Of course, if you're not in our sections, then you wouldn't have access to it, so we might do Part 1 also. But it's good practice. And ask those questions as we get the homeworks going right here. The first stat exam had a mean and a standard deviation of points. The second had a mean and standard deviation of points. Reginald scored on the first test. Oh, is that the... It's which one is it? From the quiz 5? Okay, let's take a look. Good questions. Assignment manager right here. Let's take a look. We will jump to that one. So always remember, thank you, Jamarcus, right there. We'll throw some points for asking the question and putting the parts of the question in the chat. This looks to be Part 1 quiz. So let's take a look at that one right here. Could we do the Data Analytics 4? Yeah, let's do Data Analytics 4 also. Those are good questions. Close out of all these windows. There we go. Okay, so we got the first question right here. Stat 201, Chapter 5. Quiz, Part 1. Let's go find that. And then Data Analytics 4. And then Jamarcus might have another one. Hey, Nick, good to see you here. So let's go find that question. Here we go. Okay. First and second. Okay, so it sounds to me like if we're going to compare people's scores, then we should turn their scores into whats. If we're going to compare people's scores, we should turn their scores into whats. So the first stat exam, we should turn people's scores into whats. We should turn people's scores into whats if we're going to compare them. Really good question as we get started right here. So if we're going to compare, was it here? Oh, here we go. Also, question 11 too. Okay, cool. We'll do it here next. What should we turn people's scores into to compare them? Like, how can we get people's scores to a comparative metric? Like, what method do we use to turn people's scores into something we can compare? So what do we do to standardize values to be like, oh, this one's higher. Like, you scored this on the math test. Well, your score was a this. So via your English score, you did better on math. Maybe an 88 on 2 exams doesn't mean the same thing. What can we turn things in? Caitlin's got it right there. Z-scores. Z-scores are going to be how many standard deviations you are above or below the mean. So this is a Z-score of 2.5 right there. It says Z equal 2.5 on a curve with a mean of 70 and a standard deviation of 10. So the standard deviations above the mean is 2.5 for someone who scores a 95 right there. And so with that, let's take a look. It wants to know which exam they did better on. So we need to take both of these scores and turn them into Z-scores. Let's grab the data rod here. And there we go. I'm going to close out one. I think it's just random work I created. Where did that go? Yeah, it's just random stuff I created right here. Untitled Brian Stevens document. There we go. The first Stat 1 exam had a mean of this. So we need to start highlighting what we have right here. Now, what is the notation for this? So see if you can follow along right here. These are the key learning objectives. Notation's kind of important because if you know it, you can help with kind of solving a problem. What is the notation for that? What would we write notation-wise for that? There's a few ways to write it with either the population or the sample statistic. So what is the notation? What is the notation for it had a mean of this? I'll give you a hint. The standard deviation is sigma. So what is the notation for it had a mean of this? And take these notes down if you don't have them, that the mean is what in notation? Because if we mark the problem, it's really going to help us solve it. So let's see, Jamarcus or Caitlin or Nick. What is it? And Savannah, what do you think? What is the mean? The mean, any guesses? You can actually look at the channel name. So, hint right here. Let's put a arrow. That's the observation. So, the y is the observed value. So on the first exam, they got a this. This is the observation on test 1. That's test 1 observation. It's test 1 standard deviation. So the mean is going to be mu. That's mu1. And then we go over here and we can do the second test, had a mean of this and a standard deviation with a score of this. Now, this is going to be the info for the second test, which is the mean for test 2. That's just mean sub 2. Standard deviation of second test. And thank you for answering right there. Some practice. And 2, take notes on these notations. We're just putting a 2 because this means observation of test 2. So y sub 2 means the observed value for the second test. So when we look at this right here, we need to solve both of these. And what we're plugging into for these is going to be y minus mu, observation minus mean over standard deviation. So when you think about this formula, the top part of it is just a difference between the two values, and then the bottom part of it is the standardizing of that difference. So very important to know what we're doing here when we calculate a z-score is we're finding how many standard deviations an observation is above or below the mean. So for the first one right here, we're plugging in 85, and then we're subtracting from it. Wait, did he score an 85? Well, what's his z-score? Very quickly, I got lucky on this. What's the z-score now? And why? As long as I'm not looking at this wrong. And pretty easy to tell which test they did better on here. What is the z-score and why? The average of the test was an 85. They scored an 85. The standard deviation was 2. So their z-score is what? Start drawing it out here on the bottom. Their z-score is what? It's 0. Good job, Abigail, right there. Because they scored on the mean. Now, for the second one, they scored a 77. That's the observed value minus the mean of 65. So they were 12 higher. Divide by the standard deviation of 8 equals 1.5. And if we draw this out on the bottom here, which we always want to try to do, and this is where the key learning takes place, the average was a 65 and the standard deviation was 8. So when we put the standard deviations in place, 1, 2, 3, you can see right here, you can also solve the math above, that 73 would be right here, and then 81, and they landed right here with the observed value of 77, which is 1.5 standard deviations above the mean. So we're putting the z-scores below the curve. Always remember, put your z-scores below it so you can see where you're at. You can also solve the equation observation minus mean over standard deviation to solve the value, but this is where the key learning takes place for this problem. Turning them into z-scores and understanding that we are standardizing the difference right there. So it's the second test. On the best test is, Reginald. Reginald's the... Wait, is there... Oh my gosh, there's multiple students taking this. There's multiple students taking each test. Holy mackerel. So Reginald had a z-score of 0 for the first test. And on the second test, Reginald had a z-score of 1.5. And then on the on the first test, I got to do it for another student right here? Oh my gosh. Okay, so then the other student got a 91 and then a 61. Okay, so then we got to go down here. 91 minus 85, because that's the green test, divided by 2 is 2.5. So they're over here. So that's Sarah, and that's Reginald. And then the second test, Sarah got a 61. So she got lower. So her 61 is going to be here. Sarah did not do that well on the second test. That's Sarah, and that's Reginald on that test. So she got a 63, was it? 61. So her 61 minus 65 over 8 is negative 0.5. Does that make sense right here? So we have Sarah's scores down below. So we'll go right here and do Sarah. These are all Sarah's z-scores. So Sarah's z-scores, and then Reginald is up here. So Reginald's z-scores are right here, and we see Reginald's marks with the R. So Reginald did the best on the second test. Sarah did the best on the first test. Sarah did way better on the first test. She was 2.5 standard deviations above the mean with her 91. We could go through her and mark a little bit more numbers. Ooh, wait a minute. She got a 91. See, this is where you don't do math in your head, because the 91 is 3 standard deviations. 87, 89, 91, and that 91 right there is 3 standard deviations above. She did way better. There's less variation in that test. So Sarah is 3 standard deviations above the mean on the first test. We can see that right there. Also, solving the math, great way to do it too. And so Sarah did better on the first test, where Reginald had just a z-score of 0, and because he scored the average. Sarah did below average on the second test with a z-score of negative 0.5 with her 61. You can see where it's at right there. Yeah, that's 57. My handwriting. Should stop using computers and only write things. There we go. She's right there at a z-score of negative 0.5. And then, excuse me, up here, Reginald has z-score of 1.5. So we just have to check this out. The standardized score of Sarah's best test is 3. Let's be careful because we've got 2 choices. While the standardized score of Reginald's best test is 1.5. So I think it is. Let me see. Reginald's best is 1.5. Let's see. The sum. No, we wouldn't look at the sum of... that's not a really good way. She should get the higher grade. Explain her point of view. Yeah, I think we're going to go with the second one. The way it asks it is a bit odd. The sum of Sarah's standardized scores is this, while the sum of Reginald's standardized scores is this. So, yeah, let me see right here. Although Reginald's total score is higher. Oh, yeah, okay. Yeah, so we should look at the sum because, yeah. So Sarah, if you add hers up, is going to be 2.5. And we're just adding these numbers right here on the bottom. And Reginald's is 1.5. So there we go. Because Sarah could have got a 0 on the second test, and then we wouldn't say she did better. So we'd have to subtract. That should be it right there. I'm going to delete these numbers because that's kind of a more fair way of looking at how the 2 students did. As long as we've done the math correctly, we should get it right. There we go. Pretty good question. Like it. A little tricky right there. A lot of solving. Just a lot of z-score. The final solve for it was adding up the z-scores for Sarah, and this is negative. But it's a good longer problem. I actually thought it was quicker than it was till I noticed it was 2 students, not just 1. But you know, Reginald's like, well, I have a higher score, but Sarah's like, well, the first test had less variation and I did better. So that's why her z-score is so much higher for this one. And Sarah's sum of z-scores is higher, which is a much fairer way of looking at how the students did. She did a little below average on the first test, but way better on the second test. Way better on the first test, I should say. So really good question. I like that one. Little tricky. Oh, this one's really tricky. This one. Okay, gotta remember how to do this one. Dun, dun, dun. Start to a 1. Chapter 5 quiz, part 1. Okay. I did everything else. Also on question 11, how to find the IQR. So this is going to be, the best way to do this one is to draw it out. So what you get right here is that they give you the conversion ratio between SAT, well, what ACT to SAT would mean. And so we get that, and then we get the lowest score on the SAT, or the ACT rather, and we need to convert these scores. Now you have to be very, very careful with what you're converting right here. Because if you think about this, let's take a look. If we were to take temperatures outside, let's go to temperatures. And we were to look at temperatures in Fahrenheit. So we can kind of backwork this problem to make sure we get it right. These look like Fahrenheit temperatures, right? This is like maybe middle of summer, Fahrenheit temperatures here in College Station. Try again, 78. Does that make sense what I have right here? Or we could just do it with the type of data they're giving us with ACT data. ACT data, we could just kind of work it like that. ACT data, they're showing right here, and we're converting it to SAT data. So they're saying the mean is 27, the median is 28. There's the Q3, there's the Q1, the IQR. So let's kind of work with this and do a bunch of like 20s and throw in some data right here. we go. Little low scores. And I'll explain why we're doing this. We're going to like double check our work right here and talk about the values and how they work. So these are ACT scores. And so we put in some ACT scores, and then we go to Analyze Distribution, and we can get the values on here. So now, these are the Q3, the Q1. What is the IQR right here? Which is another good thing to know how to solve. Yeah, whichever ones you want, Nick, just put them in the chat. How do we find the IQR for this? Which is a very important thing for the test. I was like making things here test relevant. What is the IQR? That's something we should know instantaneously. What is the IQR for this data? Something we should have practiced by now that we have, and I'll show how to get it. What is the IQR for this data? We put test questions just like this sometimes say, what is the IQR? And you can see the IQR, which is the box of the box plot. So you can kind of guesstimate it by looking at the number line right there, because that is the IQR. So what is the numeric? How much is the IQR? What is it going to be mathematically? What is the IQR? So really good question. We'll see if people get it. We can cheat and get it, but how do we get the IQR, and what is the IQR? So how do we get it? It's the range of the middle 50%. What is the math to get the IQR right here? So it's going to be Q3 minus Q1. So we go right here and we go to interquartile range. It's just going to find it for us. And the IQR is 11. 29 minus 18 is 11. So make sure you know how to find quantities like that and understand that the IQR represents the range of the middle 50%. Like the range would be 26 right here. So what we're going to do is we're going to use the formula they give us and compare these distributions. So let's go right here. And we're kind of basically learning more concepts from this problem, which is the goal of doing these problems. So here's the mathematics for it right there. 40 times ACT plus 150. So I'm going to go to formula. You are not meant to do all this. I'm just going to do a big solve on it. So 40 times this. That should work. There we go. So these are now converted to SAT scores. So these are the SAT scores. Once again, you're not meant to do all this. There's the SAT scores. We're going to go to tables and stack. Once again, not meant to do all this. Here we go with the data tabled stack. Now I'm going to go to analyze, distribution. We're going to go to label in the by, data here, and analyze, and we have stacked histograms. Stacked histograms are a great way to compare distributions. At this point, we really might not. This is one of those rare instances where I maybe wouldn't do the same horizontal axis. We usually do. Maybe it wouldn't be good to stack these because it's going to look kind of crazy like that, because on the same scale, they get the ACT has less variation. And it's not really good to look at. So this is what you would want if you're doing it for your data analytics assignment. You'd want the count axes, and we should probably get them the same. So that needs to go up to about 12 or so. Here we go. That would meet the standards of uniform analysis. So let's take a look right here and see what has changed, because that's actually going to lead us to the answers on the problem. So when you look at here, the maximum value would literally go through the formula. Does that make sense, Jamarcus, right there? So when you think about the maximum value and how that changes, remember how it was 31 times 40 plus 150? The maximum value has changed right here. So we're just going to go through and think about what has changed right here. So, well, it doesn't ask max, but Q3 is also a position. So the Q3 is going to go through the formula also. So we could check this with Q3 right here. There's Q3, which is 29. And you can see Q3 is just going to go through the formula. Now we have a different Q3, I believe, but if we put Q3 through the formula, it becomes the new value because it's just like the max, which is a position. So let's go to where Q3 is at. Q3 is 31. 31 times 40 plus 150. Did we do it right? 31 times 40 plus 150. Good. And that's where Q3 is at. The median works the same way because it's just a position in the data. So we should be good on the median too. 28 times 40 plus 150. And we can check our work over here on the example problem to make sure these are just going through the formula. Go to the median right here, which is 27.5, and do 27.5 times 40 plus 150. And we get the new value down here. It's converted. We're going to get to a few that change a little bit differently, though, in a moment. The mean, I think, works the same way, too. Let's go check our mean to make sure it works the same way. So the mean was 23.714286. times 40 plus 150, and there's the new mean down there. So we just go back to our data, and the mean is going to work the same way. What you notice is these are all positions and not really measures of spread. We're about to change the topic right here because everything like the mean is a measure of center, the median's a measure of center, the Q3 is a measure of center, the lowest score is a measure of position, which center is also a position. So we'll do a review of this question, but that should be the new mean. And the lowest score, same deal with the formula, 18 plus, whoops, not that. 18 times 40 plus 150. And now we get into the interesting stuff. I'm trying to think if the standard deviation, because I think this is one of the ones that will not change the same way. What is standard deviation a measure of? What is standard deviation a measure of? Standard deviation is a measure of what in data? I'm trying to answer this in the chat right here as we're working on this. Standard deviation. Yep. That's why. So that's how that works. Standard deviation is a measure of what? And that is why. Standard deviation is a measure of what? What is standard deviation a measure of? Really good question in the chat before we try to solve this. Well, you can use it to get z-scores. That is right, Jamarcus. So let's show you some points. You can use standard deviations to get z-scores, but here's the thing. Standard deviation only deals with the spread of the data. Which of these concepts on the screen, timesing by 40 or adding 150, would change the spread, dispersal between the mean, around the mean? Good answer is Abigail right there. It's a really good answer. So which of those would change the dispersal around the mean? Adding 150 to something or timesing things by 40, which of those would disperse it more around the mean? Adding 150, so I think you would add 150 to the mean also. If you add 150 or times by 40, which of those would disperse it more around the mean? And we've got the apps to kind of show this. So if you were to times by 40 or add 150, so watch this. Here's the normal curve, right? In this normal curve, it has a mean of 0 and a standard deviation of 1. If I add 150, what happens to the standard deviation? I just added 150 to every value. What happened to the standard deviation? What happened to the standard deviation? The answer's up there also. So we went from a mean of 0, center's at 0, and then we added 150 to every value. What happened to the standard deviation? Do you see it? So what happened to the standard deviation here? We have a mean of 0, and we now have a mean of 150. What happened to the standard deviation? Hint, you can see it up there in the top. We have to know why this is the answer. No one knows? Oh, I bet someone's got it. We'll throw some points here. What's happening to it? The mean is 0. The mean is now 150. What happened to the standard deviation? I didn't. Good answer, Nick, right there. It didn't go down, though. Nothing happened to it. Now watch this. Now I'm going to times the standard deviation by 40 and look at the numbers on the curve. When I times the standard deviation by 40, there's a lot more variation in the data. Let's times it by 40 again. Now you see there's a ridiculous amount of variation in the data. So the only thing that's really going to change the standard deviation here is whatting in the formula. The only thing that changes the standard deviation right here is whatting in the formula. The only thing that changes the standard deviation is what? Is it the adding 150 or is it the timesing by 40? So using that example, is it the adding 150 or is it the timesing by 40? Which of those is the one that actually changes the spread of the data? Exactly, Caitlin, that's it. The multiplication and division would change it. Because think about this. if I were to divide everyone's test grades by 10, like let's say your grades are out of, great job, Abigail, and everyone following along right there. Let's say your grades are out of 100, and then I divide everyone's grades by 10. Would there be less variation in the data or more variation in the data? If I divide everyone's grades by 10, would that decrease the variation or increase the variation? Like you got 100, now you have a 10. Someone got a 92, now they have a 9.2. Would there be less variation or more variation? It wouldn't change the shape of the distribution, but would it decrease the variation? Like a numeric spread of the data? Would the data be more compact around the mean, or would it be more spread out if I divide by 10? Because Abigail, or Caitlin, that's the perfect answer right there. If I divided everyone's grade by 10, I said, now your grade's out of 10, that would what the variation in grades? It'd be more compact. It would decrease. Yep. Oh, we did data analytics 3. I can show you where to get that, Ethan. We're going to do data analytics 4 coming up here soon. So we would times this by 40 right here, and we'd get 120. The same concept should apply for the IQR. It gives the IQR of 6. Now, here's the thing. Q1 and Q3, let's just pretend for a moment. If Q1 and Q3 are hypothetically, and I can do a hypothetical here. I'm really starting to like this question. Okay. We know where Q3 is at, so we can find Q1. Q3 is at that. Okay. Okay. So the IQR is currently what? This is Q1. This is Q3. The IQR is currently what? Pretty easy to see on here. What's the IQR? It's 6. So what happens if I add, like, let's say 3 to all these values? If we add 3 and we have 28 and we have 34, what happened to the IQR now? By adding a constant, what happened to the IQR? So now calculate the new IQR if we add 3, if we go plus 3. It's still the same value. So that doesn't change the spread, that would only change the positions. Does that make sense? It's still the same spread of data, but what would change the IQR right here? What would make these data points more spread out? They would be more spread out if we did what to the data, which is also part of this equation. Adding a constant would not spread the data out more, it would just move it over. It would shift it, as we say, scaling and shifting. So what is going to change the IQR right here? The IQR is going to change by multiplying. So the multiplication is going to make it more spread out. So we'd go 40 times the IQR, and it'd be 240. There we go. I think that should be right. Woo! That's a really good question. So you have to know which ones are changing based on what. And I really think hopefully maybe seeing the data, we made our own fake data over here helps. So I could take the original IQR. The IQR here was, we didn't calculate it. So the IQR here was originally, where's IQR? There's the IQR, it's 11. And so 11 times 40, and the IQR is 440. And then we could check right here, IQR 440. There you go. And you can also find it mathematically there. But that's a really good question. So understanding scaling and shifting, centers and spreads, just a lot dealing with kind of distributions and what changes when you change numbers. So good theory questions. Once you know how to solve it, though, pretty quick. But we like to talk about, like, what does it mean? Like, what would dividing do? It would decrease the variation, lower standard deviation, lower IQR. But you wouldn't, if you had a constant, would grades be spread out more if I said everyone gets 20 points on their test? So think about that really quick. Last question on this. If I say everyone gets 20 points, would that spread grades out more? If I say everyone gets 20 points, you get 20 points, you get 20, everyone gets 20, would grades be spread out more? Would grades be spread out more if everyone gets 20 points? So if everyone got 20 points on their test, would grades be spread out more? So you had like a 70, now you have a 90. No. So what that's telling us is the addition right here is not changing these two metrics. It's not changing the IQR, which is a measure of spread, and not changing standard deviation by adding constants. That just shifts the data. The mean is an average, so the mean is going to get shifted because the person who's the mean would get that added, and they would also get multiplied. Just think if you were the mean, that would happen to you. The median would also change, and the other positions, the min and the Q3 would change. So all these change by the full equation, and the ones over here on the right change by just the multiplying by 40 because our measures are spread. Well, let's do it. Let's do some data analytics. Thank you, Caitlin and Nick right there. Great job. Should we do data analytics 4? Let me know what other questions you have. Remember, we do the questions people ask. Data analytics 4 is what has been asked. Some data analytics. Number 4. Which one is it? Data analytics. Number 4. Pivot charts. Ooh, that's next week. We're going to do a little mini lecture over this or so. Okay, ooh, new data set, is it? Let's bring this over here. Ooh, new data set. Okay. Part 1. Which one do you want? Which question do you want to do on it, Nick? And we did all of Chapter 5, Part 1 during class, but you can always ask for anything you want right there. So let me know. Yep. So, and thank you, Caitlin, right there. More points. Let's go check out the Data Analytics 4. But we're free after this, so we can do more. Okay. 3313, Stat 201, Data Analytics 4. So with this right here, the MBA student, yeah, let me check that out. Let me write that down. What's the star of the question, Nick? Copy paste the star of the question because I'll put that in the video to help people out for the future. I think I've got it now, but drop the rest and we'll get started here after this one. Okay, so we're talking about the pivot tables and pivot charts assignment, and we've got a new data set right here. I'm going to switch over to a different data set to not use this data set because remember, I don't like doing your assignments. I want you to see examples of what to do. Oh, an incoming MBA. Nice. And so I'm going to make my own data set to work with. And so you want to use your data, and I'm going to use this data right here. Let me grab this, an incoming MBA. We'll take a look at that here in a moment. An incoming MBA. There we go. Okay. So this is data in Excel. This is just Excel data. Make sure you are using your data. This is your data. My data is different because I don't want to do your exact assignment. So use your data. Okay. So with this, let's take a look at the assignment. Once again, follow through each step right here. Use this data right here. That's the data you'll be using to create the pivot charts. See below. Good stuff. There are helpful videos on pivot charts. Yeah. And we need to link those right there. We're doing it right now. I'll throw the link in here. Create a pivot chart of your choosing that displays something you find interesting. Oh, it's just one? Where's no, not a second one? It's just one? You just got to do one pivot chart. Whoa. Okay. But here's the requirements. So create a pivot chart of your choosing that displays something you find interesting from the given data. It must contain one categorical variable in the columns, one categorical variable in the rows, and one quantitative variable y in the value fields. You have to follow this. Display the average via the value field setting of the quantitative y variable. Be careful as some, but not all columns may need data filtering. So you might have something that looks weird. We'll show you how to make the pivot chart here in a second. The write-up must be in complete sentences, paragraph format. It should follow right after the screenshot and the appropriate pivot chart. Make sure to mention key aspects and use numeric backing. So to support everything you write, give descriptive titles right here or put your name. This will be prepared by your name in the title. Descriptive vertical and horizontal axis titles. Display the data table below. And significant digits should be carried to something reasonable, like 3.75 for GPA instead of something ridiculous, and for years, something like 20.3. Here's the rubric below. Make sure to follow, like include your name, take a good screenshot. There's the visualization format with everything included on it, and the write-up, and write-up form written in complete sentences. There you go. You get points for writing in complete sentences. A write-up pivot chart includes numeric information. That's a big thing people don't do is they usually don't give enough numbers. So usually a lot of people does not contain numeric information is where they fall. They don't give enough. So we know what we have to do now. So now we got to do it. So let's put this part of the video, creating pivot charts. Where'd the thing go? Here we go. Getting started. Okay, so here we are. Stat 201, Data Analytics 4. And creating pivot charts. Okay, so to create a pivot chart, we need to go to our Excel data. And then the first thing we're going to do is we're going to hit Control A or Command A. That's going to select all the data. So make sure to hit Control A or Command A. Now, please, someone put this in the chat for 100 points. You need to have Excel on your computer. I'm pretty sure there's lots of problems if you're using the Excel online. So you need to have Excel, which is free through Office 365. You might be able to use the online, but if you're having issues, I've had some students have issues, you probably need to have Excel on your computer, which is a good thing to have Excel on your computer. So someone put that in the chat because that is huge. You need to have Excel on your computer. I don't think it can be done via Google Docs. Excel is a major important program that companies use, hence why we teach you some Excel. So we've just selected all the data, and you have to have Excel on your computer. I'm going to go ahead and write that in bold caps right here, so that way people can see if you're watching this video in the future. Download Excel through Office 365 UTK. And actually, let's even show where that's at, because someone's probably like, I can't find it. So you need to have Excel. Office 365 UTK. I'm going to log in right here and show you where it's at. So you need to go, link in the chat, look over the chat. You need to go over here to Office 365. I'm going to log in to the Microsoft 365. Pretty sure that's where we go. I don't download Excel every day. And when you log in right here, yes is where we want to be at. Okay. There we go. Okay. Let me take a screenshot of this. When you log in, you will see, so I'm going to back out. When you log in the top right corner, you will see this, Install Apps. So you want to go here to this page pinned in the chat. You want to go to Microsoft 365 and then download Microsoft 365 apps. This is not the page right here currently. It shows my emails and all that good stuff. So I'm currently on this screen. Log into Microsoft 365 right here, link in the chat, and then go to Install Apps. Make sure you have the actual Excel right here. So now that we have the actual Excel, we're going to go to Control A or Command A and go to Insert Pivot Table right here. Insert Pivot Table. Make sure you can pause the video too if you need. And now we're going to go here and go to From Table Range. Sounds good. I thought we just click that. There we go. Just click it. And then it's already got the data selected because we click Control A or Command A on a Mac and click OK. So now we have our pivot table. Now, as it said, you want a categorical variable in the columns and a categorical variable in the rows. So to do this, and I've got my pivot table view. So, where's the pivot table view? Is it this one? There it is. Perfect. So the pivot table view right here, we're looking in here at the columns and the rows, which is how we're subdividing the variables. So I want to look at whether or not, let's go to gender right here. That's the columns. And we'll zoom in on this so you can see. Now, nothing's reported because we don't have anything in the value field. Let's look at the age of students right here. And there's the age, but this is currently the sum of age. We do not want the sum of age. We want to go right here and change this under the value field setting. So the value field setting is the setting for the values we are displaying. Just think about it. It is the setting for the values we are displaying in this field. So when we do this right here, I'll zoom in on it, you can see we can show the count of individuals, the sum of their ages, which doesn't really make sense to add up everyone's age, how many individuals there are. So if we go to count, which we're not going to use, just tells you there's 451 females, 355 males. Let's go back to value field setting. You could do max. The maximum age of the males was 24, as with females. And we can change it to what we need, which is averages right here. Just kind of showing the differences on what we get. Now, the first thing you'll notice right here is that this has bad decimal formatting. What you want to do is, if you want to make your life easier, remove everything but the value field. So we still have the value being displayed, and we're going to click the one value being displayed. So make sure you've removed your other things and only have the value you're looking at right here. With only this value, click on it. Boop, and you should see everything in your table appear, and then go to Home. Now that you're on Home, you can decrease the decimal format or increase. I want to decrease. As it said, age or something is probably good to 1 decimal. So now we've got it. And when we bring back the other variable, like gender right here, it's actually going to format everything. So that's why I highly suggest only doing it with the value right there. And you only need to format one value. Once again, the steps for formatting the value, we'll unformat it here again, is to have something in your table with the value being displayed for the average, then click it. Once you've clicked it, go to Home and click the decrease decimal button right here. So that's the decrease decimal, and we've done it. So now I can divide by gender or subdivide them into smaller groups. And then I could take something like distance from campus right here, which is a little bit more interesting because when you think about it, people who are further away from campus might be older. Now, this is what's not required, but I do like doing it. You can reorder these so you can move them around a little bit. You have to be right there. It's a little hard to do. Not required, but can definitely help your graphic and what it's communicating. So now we have everything properly ordered. To reorder things, click them, and then go right to that little thing that's hard to find. If you're having trouble doing this, this is not required. So if you can't do it, don't worry about it. Not required. And you do see that the people who are on campus are a little bit younger, and we start to see the age increase slightly, but interestingly, the 30-plus minute drive is where the trend stops. Now, this is not a great way to display data yet, because this is just a pivot table. We now need to go from a pivot table to a pivot chart. To get a pivot chart, you want to be clicked inside of your pivot table and go to the Pivot Table Analyze button. Under Pivot Table Analyze, you want to go to Pivot Chart now. This will insert the pivot chart. The default format is what we want to use. There are other ways of doing it, but they don't always look the best. Luckily, this one works well with the default. Let's go ahead and click OK, and it makes the default analysis. Now I like to zoom out a little bit here and bring this over to a nice spot to work with. And we're going to bring it right over here and ignore what we created there. You have to create the pivot table first, but we will not be using that pivot table again. Let me put this in bold. Do not include that pivot table you made. Do not include that. That's a common error that people have when doing this assignment, is they include that pivot table. We'll be making our own data table next. So include the data table. So we will be making a data table here to go below this pivot table or pivot chart right here. And look, we can really see the trend. And males just tend to be older, but there's a trend that stops around the 30-plus minute drive and just reverses itself. So we're going to go here, and on a Mac, you have to click on it and go to Format. No, not Format. You have to go to Design, and you have to go to Add Chart Element. Now, we can also do it over here on a PC, but I think that's not available on a Mac. So we're trying to show it for both right here. You can go to Design and Add Chart Element. Also, there's Quick Layout, and this Quick Layout has pretty much everything we need. Now be careful, because your graphic might look a little bit weird. So if you pick a Quick Layout and your graphic looks something like this right here, that's not something you want to turn in. So try to get it to a nice format where it's like, yeah, this looks pretty good right here. You can also do things like click the text. So let's go in here and click the text. And I believe if we're here and click the increase font, it'll increase or decrease font. So get it a way that people will be able to read it if they're looking at slides, and think about how you want this to look. Clicking any sort of thing here and increasing or decreasing will help out. But there's one thing we're missing right now. We are missing an X-axis title. The X-axis title can be found either here under the plus. Mac users don't have this. So for everybody, we're going right here to the design and going to add chart element and going to axis title, primary horizontal. Now that we have a primary horizontal, we might go right here, see the size of the font. It's 10. That is 10.5. So let's just call this 11. And let's just call this 11. You want your chart to look really nice. So now, this is pretty clear. This is gender. This would need to be distance from campus. And then this over here needs to be, this would be average age. And now, I'm going to make this a little taller. Zoom out a little bit. There we go, like this. And now we have average age of students by gender and distance to campus, and then prepared by Brian Stevens. How's that going to look? Don't like that does that. We're going to decrease this font a good bit. There we go. There we go. That's what we want. I think that's looking pretty good right there. And just think about how it looks. That is key to making graphics. I like that this is in one line. We could even go right here and bold the whole title if we want. It's whatever you want. Be proud of the graphic you make. That's a key thing I try to tell students is be proud of the graphic you make. So now that you have the graphic, you should see axis titles. You should see y-axis and x-axis titles. You should see your different groups. You have two categorical variables it's split apart on. You have the quantitative average for the y variable of interest. And you also have your title with prepared by your name. So now we need to go and take a screenshot of this. I prefer to take a screenshot because I can kind of edit. I don't like these blue things in here right now, so watch out. You might need to click away from your graphic. I don't want that in my graphic shot of the screenshot. There are other ways to import the graphic, but I prefer to take the screenshot I want, and there's the screenshot I want. Once again, if you get too much in the screenshot, like if you did this right here and you have too much, we can fix that. So it's better to get a little bit too much than too little. This is too much, but we're going to fix it. Once you bring it over to Microsoft Word with copy paste, like insert and then paste, or is insert paste or Control V? For those wondering, we use snipping tool right here, and I have a video on how to add graphics. Please let me know if you cannot add the graphics to it. But we went, and I'll explain briefly what I did right there. I went to snipping tool on the PC, and you can do Command-Shift-4 on the Mac. It's going to put this into my copy, and when I go over here to Microsoft Word, I'm going to hit Control V on a computer or PC and Command V on a Mac, whichever applies, but the Command V Mac or Control V PC will paste the image in. Now we click the image and we go to picture format. If you properly took the picture, which I didn't, you don't have to crop it, but we do. The crop, I like to do each side individually. You have to grab the little black bar right there and just pull it in until you see what you want. And then we're going to remove that top thing right there. And this is just doing the same thing we did earlier, but removing the extra parts we wouldn't want to see. The point of this is if we put this in a presentation, it would look really good to people. You can do like that's a great border. I started using that a little bit. You could do a little shadow effect, whatever you want. Be careful. You don't want something to look crazy like that. That wouldn't be good, but that's good right there. I'm more liking that one these days. A little shadow effect, but looks really nice right there. And I would say, if you make a graphic like this for your company and you want to compare things, pretty good. So now what it comes down to is writing an explanation. We now have to write a written description. Hey, Andrew Wynn, good to see you here. We now have to write a written description of this comparing. And think about the first thing we see. Well, we need to start citing the trend right here that as we see people go further from campus, we see the age increase starting at 19.0 for females and 19.4 for males, going up to more than a year older for males, 1.4, or for females, that's females right there, 1.4 years older to 20.4 when they're a 10 to 30 minute drive, and males go to 20.7. So both of them increase about the same rate. And what's also really interesting to me is that we see that the the really far away students, the 30 plus minute drives, don't follow the trend. So the 30 plus minute drives are actually closer to the average age of students who are on campus, at least for the females, where the males are closer to people who live in the fort. But it's weird that everything follows that trend until you get to the furthest distance, and then it goes against the trend. Also, we see at all points that males are higher than females with their average age. For example, the average age of males who are 10 minutes from campus is under a 10-minute drive, under a 10-minute drive is 20, where the average age for females who are under a 10-minute drive from campus is 19.7. So the biggest thing right here on your written explanation is going to be writing it up and comparing these numbers, talking about maybe the trend you see in the data, things that go against the trend, differences between the groups. All these things right here are important in citing the numbers. So the hardest part about this is I can't write your report. I can't write what you see. So I'm using different data. So you have to create your own graphic. Now let's talk about what could go wrong. Let's do a quick section on that, and then we'll do the MBA question. Kind of what could go wrong. What'd you say right there? I see a question. What does the SM mean in our data? Ooh, good question. Let's look at that here next. Did we give you a data dictionary? We should have. 5223, stat 201, data analytics 4. What could go wrong? Errors, call it errors. Like SM Entertainment. Good question. What is that? SM Entertainment. Oh, social media. Social media entertainment. It's where people get their social media entertainment, where people get their social media news. social media main usage, their relationship status. That's SM for social media. So their view on crypto currency, all the pretty interesting data to work with right here. And you've got some quantitative wise to start. So here's what could go wrong. I'll do it on this to show you what could go wrong pretty quickly. So this is not where I'm showing how to make the graphics. If you're watching this, this is just me showing what could go wrong. So once again, same process for the same data. Here's where things could go wrong. Can anyone identify the major problems? What went wrong right here? Can anyone identify, this is what could go wrong, so I can make a bad graphic now. Can anyone identify what went wrong right here with this analysis as I kind of make it up as we go? Ooh, whoa, whoa. Yeah. It went really wrong. Oof. Can you identify what went wrong right here? And you probably need to look over here. What went wrong with this person's analysis? I'll answer the question on what went wrong with this person's analysis. I don't want to do any proper analysis with this data, but what went wrong? What requirement did they get wrong? And it's going to make a crazy graphic for them. Here's a hint. What kind of variable is age? What kind of variable is weight? And then if you compare it to the work we just did over here, gotta go back to the table. What kind of variable was gender and distance from campus? So what happened here is in this one, we use a categorical relationship, and then we put a quantitative Y right here. So this creates the proper graphic with categorical right here, categorical here, and quantitative average. The second one we created right here used quantitative right there. Age is quantitative, weight is quantitative, and then average height. That is correct. Average height is right. I'm not going to make any proper graphics with this data because I don't want people to copy what I do. But any quantitative variable right here. So you have to know what your data is. You have to look at the data and be like, okay, that's categorical, quantitative, categorical. Pretty easy. And then number of, what is this? Number of streaming services they use. So quantitative also. Pretty easy to tell which ones are quantitative. Here, I'll highlight these as quant. And then these are cat right here. There is no identifier in this data. There's no unique observation for each individual. Not the end of the world, but because we don't really need it. But there's the quant and the cat. Does that make sense? Oh, I'm still zoomed in on the side. There's the quant and the cat data. So you've got 4 quantitative variables and 1, 2, 3, 4, 5, 6, 7, 8, 9 categorical variables. So the categorical variables are someone's gender, the year in school. Then we have age, quantitative, height, quantitative, weight, quantitative, born in Tennessee, yes, no. Categorical, relationship status, categorical with different categories right there. Social media main use, categorical. Social media news that they get from, categorical. Social media entertainment they get their entertainment from, categorical. Number of streaming services they have, and then their crypto view, categorical, and do they have a food allergy, categorical. So hopefully this all makes sense right here. You want to know your data before you analyze it. And really good questions, Caitlin. So if you get a weird graphic like this right here, you've done something wrong. Please reach out to me. Let me know. Be like, hey, Brian, my graphic's looking all crazy like. It can happen. It can happen to multiple people. You don't want that to be your graphic. If you turn that in, grade's not going to be so great. But we can work on it. Start early. Ask questions. Let us know what's going wrong. And pivot tables and pivot charts are a great way to analyze data. And everyone, not everyone, but Excel is a ubiquitous program. Pretty easy to use right there and pretty easy to get the hang of. So that's why we teach it. Heading over here to the MBA question. What more questions do we have? I might do some Business Analytics 320 if we don't have more questions after this. But what questions do we have? We're running low on questions. We need more questions. More questions. More questions. I solved it already? Oh my gosh. Well, what should we do then, Nick? You've already solved it? No! Should we do some chapter 5 part 2 a little bit? Or I could get started on making about to post the 320 assignment. Maybe I'll do that really quick. Post questions in the chat. I'm gonna get the 320 posted real quick. Their assignment is working off the same thing from last week of sorts. Let's go here to assignments. You don't have to go to the NBA. I figured out. Yeah, well, great job, Nick. That's what we like to see. So, duplicate. Okay. How are people doing today? There we go. How many sections stat to 1 are there? I think there's like 11 or 12. Good question right there, Nick. I think there's like 11. Might have more. How many? Yep. I think that's got it. Just gonna make small updates to the rubric now. Oh man. I pressed it. Oh, cool. Oh, yeah. The flashcards? Yeah, you're in the asynchronous then. So good to have you here, Nick. Well, Nick, do you want to just do the fall homework part 1? Because, yeah, if you're not in our section, you wouldn't see it. Do you just want to do the fall homework part 1? We could work backwards if you're currently working on it. Do you already have 100 on the homework? And thank you, Nick, thank you for being here. Well, I mean, maybe if you want, I'll tell Terry your bonus or L. We want to be equal to everyone, so Terry, they have their own bonus. So you just write down the flashcards and you upload them. That's what you have right there, Nick. But what do you want to work on, Nick? That's why you wouldn't be able to see the chapter 5 part 1 we did in class. What do you want to work on? Let's get some work knocked out. So I'm glad to have you here, man. I never wanted to be like, oh, we did that in class, so we're not going to do that. I'm so proud we got multiple people here across multiple sections. And that's one of the things, if you're in an asynchronous class, I bet, do you want to review something, Nick? Like the asynchronous, shout outs to you, man. Asynchronous is tough. I teach asynchronous. What do you want to do, Nick? You name it. I actually just got the Kaggle assignment posted. An update to their original Kaggle assignment. So I was able to get it posted and going right here. So that's posted. So I did that in that little short time right there. Got their Kaggle assignment part 2 posted because it's off of, I'm on chapter 5 part 1. Let's do the full homework. You ready? Because I bet you let's go through and do that. I bet you someone's going to be really happy with this. Let's do it backwards. So that way, if you're working on it, we're going to do the full chapter 5 part 1 homework backwards. And once again, shouts to you because asynchronous is tougher. A lot of times, if you say, here, go learn it, it's not quite learn on your own. I mean, everything's learn on your own to a certain extent. That's why I was confused with the structure. The asynchronous. It's tougher. It's tougher. Here we go. Yeah, jump in here anytime, Nick. You can always be like, hey, Brian, can we do this? Can you explain this? Can you lecture? You can even ask me to review a concept, Nick, if you want to say, hey, Brian, can you review this concept? Chapter 5, homework, backwards. Okay, let's do this. You're welcome. Yeah, company customer service hotline handles. Let's do it. Okay, company customer service hotline handles. Here we go. Here we go. Ooh, this is a good one. So a company, here I'm going to change. I said backwards. So we're not quite doing it backwards. We're just doing it in like, okay. So now here's the part 1. Okay, here we go. Chapter 5, homework, part 1. Let's do it. A company's customer service hotline handles calls relating to orders, refunds, and other issues. The company records the median. And this is similar to a question we did earlier. The median is a measure of center, and the IQR is a measure of spread. So if the company wants to describe the duration in calls in seconds, and think about this, like just put it to something you know. Like if you were to run a race and it took you 10 minutes, or let's just say you ran something and it took you a minute to run it. It took you 60 seconds. Now the IQR is the spread in the data. So if we convert the IQR to seconds also, it would still convert because it's still got the same distances. This is similar to a question we worked earlier where we times the numbers by 40. So if you look right here, the mean is 23 point, let me disappear. Check out the one way earlier in the video from chapter 5 where we times this by 40. And that's going to be, oh, and then we added also 150. We're not adding, but the other one has you add to it. So you're still timesing or dividing by a certain amount right here, which would also change the IQR. And the IQR, if you have 11 and you times that by 40, the IQR would change by multiplication. So multiplication, I guess is a quick note, multiplication changes the median and the IQR. Multiplication would change the median and the IQR. So the new median right here, since we're going 5.92 seconds, let me move this to where you could see it, is going to be 60 times that. And we just go right here and drop that. The new IQR is that right there. So that should be the new values for both of those. Now, here's the thing. If we speed up the process, this is what we talked about earlier too, you're just shifting the data. So right now, the IQR here, let's say this is how many minutes it takes for you to take a test. And the spread is 6. But if you speed up by 10 minutes, and both of these are now 10, oh, whoops, didn't change that one, 10 minutes. What is the new IQR? And it might work better if I show it. I think I can do a better example. Let's say I have test scores. So I'm going to put these in order right here. Tell me, Nick, what was the lowest score on the test? So tell me what was the lowest score on the test. Not meant to know how to code, but tell me what was the lowest score on the test. The lowest score, they are in order, was what? It's a 61, right? So check this out. If I go right here and I go to the range of test scores, it's just going to be that range, right? So that's the range of test scores. And let's do it where we get the actual range. I wish it reported that. I'm going to take right here and report the range. But what if I were to do this? If I were to go to everyone's test scores and say test scores curved, and I go to their test scores, and I add, oh, we don't want test scores curved yet. Test scores plus 10. Do you see everyone had 10 added to their score? So the range of this data for the test scores curved is still 39. We didn't change the spread of the data. Does that make sense? We didn't change the spread of the data. So adding a constant to everyone's score wouldn't change the spread. But look at these test scores. Did we change the median? And that is the median's between these numbers technically. Is the median changing right here? Is the median changing? Yeah, exactly. That's what it is, Nick, right there. Did the median change? Did the median value change? Yes. So think about it. If you were the median, if you were the 50th percentile, you'd get 10 added, but we're not spreading people out more. If you divide by something like if I were to say here and say test scores out of 10, so out of 10's ridiculous names, we could take the test scores and divide by 10, And then this would change the spread of the data and the center. So now if you look at this, the new median is going to be between these two numbers. So that changed the median and the spread. So here's the short notes. You ready? Dividing, multiplying, adding all change the median. They also change the mean. Let's write that. Kind of cliff notes on this. So dividing and multiplying, dividing and multiplying change mean, median, IQR, standard deviation, range, pretty much everything. I think it changes everything as far as I can tell. I can't think of one thing it doesn't change. Question on get a chance, are the values percentage? They might be. It depends on which ones you're working with, Caitlin, right there. Mine were not because they were ages. You might have to tell me which one you're working with or send me a screenshot. I might have to look. And then those right there, change that. And then adding and subtracting, change the mean, median, IQR, min, max. They don't change the last ones though. They don't change standard deviation. Does that make sense? Just think about if you had the highest grade in the class and I added points, that would change you. So try to use examples where you're like, I had the highest grade in the class and Brian added points to my grade. My grade's now higher. I had the lowest grade, the min. Brian added points that changed my grade. My grade was at the mean. Brian added points that changed my grade. But the when we add values to it, it wouldn't change the spread of the data. So also IQR right here. That would change when you divide or multiply. But adding would not change these last three. Let's put them right here and kind of highlight them. Those are only changed by dividing and multiplying, and adding and subtracting would not change those. These are changed by these. And that's kind of the cliff notes for these questions that do these sorts of work to get them right. So the new median is going to be 24 seconds faster. And so that's 330. And then the spread does not change, and we get it right. So yeah, I mean, once you know the tricks to these, or if you understand the concepts, you can get them right. 330, and then right here, 120, 144. Trying to do it in my head. Good job. And then we speed it up by 30 seconds, 300, 144. And that's what you want to get to with those. Which other ones are you working on, Nick? Shifting data, to show what this looks like visually. Shifting data is changing the what of the data. When you shift data, here's what shifting looks like. And look down there at the bottom. I'm changing, starts with a C, the what of the data. Shifting data changes the what. Like if I say, oh, the average grade was a 78 with a standard deviation of 5, and I say, let's add 10 to the grades. Not conditions. Good answer, Nick. The center of the data. So if you see the average grade was a 78, but I'm going to add 88, I'm going to add 10 points to it, it changes the center. This is called scaling data, and it changes the spread. You see how the number line is getting more spread out? Or if I decrease it, this is when you like divide, so I'd be dividing it by. What's the difference between the center and the median? Ooh, do I still have those notes up? Really good questions, Nick, right there. Chapter 2 notes, really good stuff right here. I take screenshots of any of this if you want it. Here's the Cliff Notes version that I wrote down, where the center has two types of things we use, the mean or the median. Now, I've got these paired together that if you use mean, you use standard deviation. So center is just a measure of where kind of the middle of the data is at. But the type of center we use is based on the shape. So since this is a very skewed data set, we would use the median. Does that make sense? For center. Now, spread is a metric of how spread out or the variation in the data. And so since we said median, the proper measure of spread would be IQR. Now, these are great review questions, Nick. So keep asking. We first talk about shape, and then shape determines proper center, proper spread. And if we say mean is the proper center, well, then we had data that looked more normally distributed. Kind of normal. That's categorical data up there, so we don't want to look at that. There's normal data. So this would use mean and standard deviation. There's skewed data, so it would use median and IQR. This one's symmetric, so it's kind of a it doesn't matter. Kind of a 50-50. These are very skewed, so we would use median and IQR. Median for center and IQR for spread. Once again, understanding when we talk about center, we're talking about where the middle of the data is, and center is either mean or median, and spread is either standard deviation or IQR based on the shape of the data. So really good stuff right there. Will there be normal with no symmetry? Normal requires symmetry. So you could have, here we'll do some graphics. If you have unimodal symmetric, okay, so let's do the two qualities that make, okay, so unimodal symmetric. And then we have, let's just say just unimodal and just symmetric. Okay, so the two quantities that make something normal is unimodal symmetric. Now, there is something called kurtosis right here. So you can draw the unimodal symmetric with kurtosis, with higher kurtosis. I think this is like maybe like a 3 kurtosis. And then this is like maybe the 1 kurtosis, I think. But we don't get into that big of detail, but both of these are unimodal symmetric. Now, unimodal doesn't mean it's symmetric. It could be skewed. So unimodal might look something like this right here. We might have some sort of skew to it. Symmetric doesn't mean it has a modal area. It just means it's got symmetry. So you could do stuff like this that's symmetric. Does that make sense? So the unimodal symmetric curve has the one mode. So when we go to the unimode, we're talking about this. These are all unimodal. And the symmetry down here on the bottom, when you have symmetry, you're going to be able to fold it over on top of itself. So the folding of it is the symmetry. Those are not symmetric. So these down here are symmetric right here, but they're not really unimodal. That one's uniform. So they doesn't meet the two qualities. Yep. So that's a really good review right there to understand those words and what would just a unimodal distribution look like. I wish we could, these would be great test questions right here, but trying to understand it and draw these things to be like, okay, what if something is just symmetric but not unimodal? Well, then it's got multiple modes or doesn't have any modes, where this right here is going to be uniform, and this has bimodality. So that's bimodal, and these are right skew. So right skew, we draw our little monster man right here. He's got the tail right there, and this is left skew. And for those wanting the upper level version of this, I did mention a kind of more advanced topic. I do like to throw those in there every once in a while, called kurtosis, which is often thought of as peakedness. It's tailedness, it says. And Wikipedia has an article on kurtosis right here, which shows graphics with higher kurtosis. And I was right, that is the 3, and the normal curve is that the normal with negative 0.59? That's weird. I don't know that. Oh, no, normal is 0. Normal is 0. So the kurtosis of the normal curve, if I drew a good normal, is 0. Where it says tailedness is the better way to talk about it. Like, if you read the Wikipedia article, it'll be like, kurtosis is often thought about as tailedness, but that's a misconception. So, or peakedness. It'll be like, that is not what it is. Hence, the sometimes seen characteristic of kurtosis as peakedness is incorrect. I talk about it as tailedness. I don't know. What helps me understand it is how peaky is it? I don't know. I need to read the Wikipedia again on this. I've read it a few times. I don't get into the mathy part. What does it say? The standard measure of kurtosis, originated by Carl Pearson. Ooh, Mr. Pearson right there. Is a scaled version of the force moment of the distribution. This number is related to the tails of the distribution, not its peak. It's tailedness. So yeah, neat stuff right there. More related to the tails, but yeah. Measure of whether the data has heavy tails. Yeah. Good answer. So heavier tails, is that what it says? Yeah, is it Sloan? Good answer. Sloan, great job. Good to see you here. You don't need to know kurtosis, but that's really the only thing that changes about it. Like the only different metric I'm changing between these. Both of these are unimodal symmetric, but the curve on the right shows more kurtosis. I guess it doesn't have as heavy of tails, right? Hey. Where the normal curve is where we set it to 0. I should remember that that's 0. I just remembered, I don't know, I just knew it as peakedness. I just used the miss idea. Maybe I should use the right answers for what we do in statistics, right? Nick and Sloan, what are you working on? And there's a screenshot on Discord. Let me go check that out. Okay. Yeah, it's looking good. All right. Yeah, that's not a percent. That's average age. Yeah. This looks, well, oh, it's not percent. That's average age right there. So that's not going to be percentages, and then some groups don't have individuals. So that's not a percent of individuals who do that. You're looking at the average age of the individuals who use Facebook. Does that make sense, Caitlin, right there? So I'll see if you reply in the chat, but this is the people who reported using this of that group. What was their average age? It's not a percent. Yeah, 1, 2, 3, 4, 5, 6. It can't be a percent because it doesn't add up to 100. And because it kind of looks like that, but that is average age. Yeah, so that's the people who use this in this group or this average age. And then you can take a look. Really good job right there. That's excellent. Which was the answer of the shifting data? Yeah, we didn't finish that one, right? I love Discord. Shifting data by adding constant will do what? Does not change the what? So can you name 3 things? You got it, Sloan. 3 things that shifting data would not change. By adding a constant, 3 things shifting data would not change. By adding a constant, 3 things that shifting data would not change. Shifting data is adding and subtracting from it. You're moving it left and right. Shifting data would not change what? 3 things that shifting data would not change. And we can see it if we go back here to the app. You can see if we shift this data, we're just moving it left and right. So you see how it's moving along the number line? But look at like the start and the end of it. Those 3 things, you got to slow right there. Those are the 3 things that wouldn't change because all of those are measures of what? Every one of those is measures, and I'm changing it now. All of those are measures of what of the data? Got it, Nick? Yep, because every one of those is a measure of the, starts with an S, the what of data. Shape, center, what? All of those are measures of spread. So it wouldn't change the spread of the data if we had a constant to it. So right here, shifting the data would not change the standard deviation. And that's got it right there. Good stuff. Should we do this one right here, Nick? You name it, Nick. What should we do next? This one's a pretty good one on the 68, 95, 99.7 rule. What should we do? Okay, let's do it. So choose the model. We already did that one. Oh, cool. So which one do you want to do here? Tell me the number to do. Next one. Cool. You got it. Okay. So which of these is true about z-scores? Can we use a z-score to standardize data? If you go back here to the start of office hours, can we calculate someone's z-scores to standardize to see where people were at? Like to compare Sarah versus Reginald right here. Can we use z-scores to compare people and standardize scores? Are z-scores used to standardize scores? Are z-scores? Yes, that's the big thing. Then you know, like, how well did you do in this distribution? Because the z-scores are always the same, but the distribution may be different. Can z-scores tell us how many standard deviations a value is away from the mean? The absolute formula for z-score, which we've written down a few times today, is observation minus mean over standard deviation, which is the distance it is away from the mean over the standard deviation. So that's true also. A z-score has a mean of 0 and a standard deviation of 1. If you want to draw the standard normal curve, you put a mean of 0 and a standard deviation of 1, and everything down there would be a z-score now right here. I need to tell Adam we probably need to update that to not say z. Oh, it says, whoa! Look at this. When he, oh my gosh, Adam is a genius. If you put a 0, 1 on here, a mean of 0 and a standard deviation of 1, it then tells you this is a z-score. If you change the standard deviation, this is no longer a z-score. It's just the observed x value. So that is absolutely amazing that he has it changed to now it's telling you this is a z-score because z-scores have a mean of 0 and a standard deviation of 1. So I'm completely impressed by this. That is really, yeah, he really thought of everything with that. I've yet to see an app do that. Yep. So it's literally saying you now have a z-score with a mean of 0 and a standard deviation of 1. And if you change this right here, it's going to tell you it's not a z-score because it doesn't have the proper mean of 0. So those are z-scores. So that is amazing. So that is very true. A z-score is a measure of how extreme something is. It can tell us, depending on if it's way over here, like at 4 or -4, or 3 or -3. Once again, something isn't unusual at a certain z-score. It's just that things are more and more unusual. Who is more unusual? A baseball player who hits 50 home runs or a baseball player who hits 51 home runs? Who is more unusual, 50 home runs or 51 home runs? Because we could say the average baseball player hits in a season 20 home runs with a standard deviation of like 8. And so you can see 55 or 50 and 51 are way off the curve over here on the right side. So 51 would be more unusual, right? So is 50 not unusual? Is 50 not unusual? Like 51's more unusual, right? Over here at 51, that's more unusual. But both are pretty unusual. So what is a lot of home runs in a season, Sloan? Like what would you say is an unusual amount of home runs? Like what would you be like, that's a lot of home runs? When would you be like a baseball player got a lot of home runs? Like at what point do you think you would consider that? Because these are the deeper understandings I want people to have about statistics and why it's all like, well, kinda. At what point would you be like, that's a lot of home runs in a season by your favorite baseball player? 24, 40 is really good. So let's say a baseball player, Nick, hit 39 home runs. Would you be like, that's like pretty common? If 40 is a lot, let's say 40 is unusual. Is 39 common? Is 39 just an everyday common occurrence? If 40 is unusual, and we're like, 40 is a lot, would we look at 39 and be like, it's just like every day? We'd look at 39 and we'd be like, it's kind of unusual. It's not as unusual as 40. So what I'm saying is, if you have a z-score of, let's say, 2, which we consider unusual, is a z-score of 1.98 not unusual? For the average, 39 would be, yeah. Is 1.98 not unusual? Now, we like to say outside of -3 and +3 are definitely outliers. Outside of 2 and +2 are pretty unusual. But is 1.98 z-score not unusual? Is the z-score of 1.98 not unusual? It's all the way over there on the right side of the curve. I mean, if we're saying 2 is kind of unusual, then, I mean, yeah, it's kind of unusual. It's just as you go down, can I do it by decimal points? Darn it, does it? As you go further, they become less unusual as you go towards the center of the curve. As you go further away on the curve, it becomes more unusual. But once again, it's not like 1.98 is not unusual and 2 is unusual. It's just the further you are away from the mean, the more unusual you are. Positive or negative doesn't matter, just the further you are away. So what's the answer to this question right here? All of them. Yeah. But don't, remember, we show the answers here. Once again, this question, there's no reason to get it wrong because you get infinite tries on it. And so this is one of the ones where I'm not afraid to show it because, I mean, you get to try it a billion times. So that's when people don't get the homework done. I'm like, no. Do you have 100 now, Nick? Sloan, do you have any questions? And great job, Nick, right there. Earning our own some points. What questions do people have? Let me know. Drop them in the chat right here. Just let me know any questions you have. Yeah, let's head back to the main scrolling. Which one do you want to work on? Which number question, Nick? If there's a question you have that you don't have 100 on, let me know. Got lots of good questions. Someone tag me in the chat here. 320 tagged me. Yep. Lamp every. Lab on Thursday. Is it on the quiz or on the homework? Oh, on the quiz, is it? Oh, but you can hit try again. Is it on the homework? On the homework, you can do try again, try again. So there's always similar question on the homework. The homework you get infinite attempts on. The quiz you get 5 attempts on, excuse me. So you should have, if you go to the question, you've completed it. So let's say we go through and we complete the question. Daniel X3, we can talk about that here in a second. You got it. So if we go through here and we complete this. Oh, wrong one. So let's say we get this one wrong. Well, I want to get this one right. That's within 2 standard deviations. And then above 132, 2.5. And then above, what does it say? Between 52 and that's 2.35. And above 148, that's 0.15. But let's say, does it have a give on this? Oh, no. So we made an error. It should be 0.15, but it's going to get mad at us. There we go. So now we got it wrong, but Nick, do you see where it says similar question? You should be able to get a similar question. Does that make sense? Does it have that ability for you to do it? What would you recommend in the write-up? Comparisons of, that's exactly right there, Sloan. Do you want to do this one again, Nick, real quick? And we could actually work your version of it and get you 100 on it. Because that's what we're doing. Hey, Jesse, good to see you here. Let us know if you have any questions. Nick, what does yours say for the mean and the standard deviation? What does yours say for the mean and standard deviation here? What does yours say for the mean and standard deviation? And make sure to quote numbers, Sloan. Make sure to quote those numbers. What is your mean and standard deviation? I'll draw yours out. 100 and 140. So this is what you want to practice, especially for the test, is you take and draw the curve, and then you put 100 at the center, and then you go up by 14, and there's the numbers, and 86, 72, 58. And then we always put the z-scores below it. Z-scores are always going to be the same, telling us how many standard deviations those are above or below. There's your drawing for the curve. Just takes a few seconds to draw out, especially with practice. Maybe a minute or two, but more practice you do, the quicker you can draw it. Now we're going to write the 68, 95, 99.7 rules. So once we've drawn this out here, the questions are going to get a lot easier. So Nick, what's the first one asking you? So we've got the curve drawn right here. Make sure to select the proper curve. We've basically given the drawing they have with the z-scores. So what is the first one asking you? Between what and what? Above what and what? Middle what and what? So, and then, like, you should get 100 here. We'll try to get this. We'll get this. I think we can. So what's your first one? 99.7. So you have to go plus or minus how many z-scores? So when you hear 99.7, you'd say, I need to go plus or minus how many standard deviations around the mean? And then I'll highlight the answers once you answer that. 99.7 means I need to go plus or minus how many standard deviations? How many standard deviations would we go? So the middle 99.7 is always plus or minus this many standard deviations. So the standard deviations are along the bottom right here. And the middle 99.7 is always plus or minus this many standard deviations. Is it 1, 2, or 3? So the middle 99.7, 3. Well, then also we go positive 3 and negative 3. So we're going across here. So plus or minus 3 standard deviations is the middle 99.7. So this should be the answers right there. 58 and 142 is the range of the middle 99.7%. What's the next one? And tell me if you get anything wrong or anything, just because, you know, I make errors every once in a while. What does the next one say? And good work, Nick, right here. The next one asks us what? Above 128. So above 128 is right here. So what we want to do is we want to talk about the outside of this. If 95% is inside, what is total outside? So tell me the total of both those arrows. If 95% is inside, what is total outside? So I'm asking total right now. Because 95% is inside. What is total outside? Great job, Sloan, right there, 5%. So what would be the answer? So if this is 5%, what is the answer now? Remember we just said it's 5% total? So what would this answer be? You see what Sloan has right there? Instead of the 5%, because we're just subtracting from 100, it's going to be 2.5 right there. Great job, Nick. So is this making more sense? I hope the visuals can kind of help that we're saying, oh, if 95 is inside, 5% outside, because that's out of 100, divide by 2, exactly. Yeah, no, you're doing great right there, Nick. And thank you, Sloan, right here. Good job, too. Let's throw you both some points. Okay, what's the next one say? So the drawing makes it way easier. I highly suggest drawing these out. And then you'll understand better what the z-scores are, the 68, 95, 99.7%, the amount of percent of observations contained within the values. What else do we have next? Between 58 and 72. Now, this is a tougher one. This is a tougher one. But we just said, now review what we just said. We said below here, do you remember the answer we just gave? It's 2.5. But that's completely below here. We need to subtract off this area. So how much is that area right there worth? Sloan is on track. So you could Think of this. If 99.7 is inside, then 0.3, great job, Jesse, too. And drop more questions. We got a little more time. So we're dividing that in half. That means this is 0.15. So do you see the mathematics we're doing, Nick, to get the answer? Because we only want this area right here, which we know total, like across here, is 2.5. Like if you went below there, but we're not saying below here right now. We're saying between these two numbers. And so Nick sees it. We're just subtracting from 2.5 to 0.15 to get the answer. And then, so it's 2.35 for that one. What's the last one? Or there was one more probably. What is the last one you got? Great job, Nick. What is the last one? Let's see. Above 142. Ah. Wait, Nick. I want Nick to answer this. Nick, what is above 142? So what is above 142? And use the same tricks we've been doing. Use the same tricks. Do the quiz 5 times for fun. Exactly. You got it. So, and then check this out, Nick. Amazing work, Nick. Earning everyone some points. Sloan, great comments right there. If you add up all these numbers, because you're going across the whole curve, you see how the arrows like connect now? They run across, and you could like do it as a rail line right there. Now with this right here, you have 100% of the data contained. So that is 100% of the data if you go all the way from the bottom to the top. And yeah, that is what we want to see right there is the full data set, everything. Any other questions right now? As we were just here practicing, what other things do people want to talk about? Chapter 5 is a tough one. Chapter 5 is not an easy chapter. It's one of those ones you got to practice. If you're watching this now, you're probably not waiting till the night it's due. But if you did, start these ones early. Start early and ask a question. Just jump into these office hours and be like, hey, Brian, can we work this? Especially when it's quiet like this. We just, we work through someone's problems because that's how you can learn. And I just like to ask, well, what would you do here? Yep. Let me send you the video for that, Nick. So let me go to the main screen right here. You got a really good video going over that. So sometimes I try to make like one really good video going over it. And then let me take the timestamp on this one, start adding it to the other classes. Data analytics. Okay, here you go, Nick. Yay! Thank you, Sloan, so much. There's Data Analytics 3. We're going to pin that. And then let me go and save the timestamps to this video. And then I can go to this video. Now we're picture in picture right now. Stop talking, Brian. Man, it's so crazy. Oh, wait. Timestamps are not showing up right now. Do I have an error? Maybe it's because the video is not over yet. I'll take a look at it later. Data Analytics 4, 33, 31. I wonder if I can timestamp it right now. There we go. Oh, you can't. Okay, we'll have to do it later. You're welcome, Nick. We're getting good to go right here. Sloan, do you have any questions? Got everyone working away over here. Let me grab some lunch here in a moment. I think what else there is. If I end the video, I can put the timestamps in. But people are working along really well, getting a lot of work done. Excellent stuff. Yay, my review's been finalized. Rating meeting. Well, might take a short break right here between classes, but we have class coming up here in about 53 minutes. This is for my peace of mind. I made an 87.5 on quiz 5. There were tough quizzes coming on, but that is a way better than 0. Yeah, +1 is dropped. Yeah, it was that. Yeah. Well, Sloan, let me know which ones you want to do ever. They are tougher, and don't worry. Like, the big thing is going to be learning the concepts. So if you're studying it, practicing it, knowing how to solve the normal curve, and here's the biggest thing, let's end with Canvas content. Let's do that. You ready? Let's see what the test will look like, because that's the big thing people are always wondering is, what will the test look like? Where did I close out of my notes for the video? Here it is over here. So let's do Canvas content number something. Let's do that, which we did yesterday, but you can never do them enough. Canvas content. Something, something. So we're going to do Canvas content number 3. We've done other versions of this. So Canvas content number 3. Okay. One. Canvas content number 3. Let's go check it out over here. Okay, Canvas content number 3. Let's do this right here. Let's try a version of it. Check out, I think, yesterday's office hours. If you're watching this now, that would be on the 14th. We did more versions of it. How does a normal probability plot tell you if a distribution is normal? Now, when you see normal probability plot, read it backwards. It's a plot that tells you the probability of a distribution being normal. We went over this a lot in lectures right here, where we talked about the 3 different ways to tell if data is normal. Number 1 is look at it. Number 2 is a normal probability plot. And number 3 is the goodness of fit test. When we do a normal probability plot, we can take our data and take it right here and look at the normal probability plot. This is a normal probability plot that is normal, and this is one that is not normal. When a normal probability plot is not normal, it does not follow the red line down the center. When it is normal, it follows the red line pretty decently. These are all actually being generated from normal data, so any variation you see right here is just kind of random variation that might occur given normal data, because this is a code to do random normal data. So once again, this basically follows the red line, basically normal right there. How you can tell if it's right skew? Ooh, we went over that yesterday in 320 actually. So the right or left skew, if you think about a wind pushing it, so this is if you're taking more classes, these concepts will come into play in upper level classes too. So if you think about the wind pushing it, so do you see how it's getting like blown to the right? I think of like a wind coming in and going whoosh and blowing it in a direction. That is right skewed right there. We won't make you identify skewness, but that is kind of the wind pushing it to the right. Now notice how that has some high observations. So up here, there's too much on the high side. Is there one you specifically want to do, Taylor? Let me know which one, Taylor. Tell me which quiz question. We can do it here. We got a little more time. This is normal because it follows the red line. This has some deviations from normality, and the histogram's over there on the right. This one is very much right skewed because it doesn't follow it. You don't need to know it as in depth to tell the skewness. This one has right skew in the first distribution and left skew in the second, because you got like the wind blowing it in this direction, and you can see I've circled the second modal area showing the left skew to it, and then you've got a lack of data there in the center. That's why there's that little gap in the normal probability plot. So does that make more sense, Sloan, right there? The biggest thing for 201 especially is going to be, does it follow the line, normal? Does it not follow the line, not normal? And so that's the main concepts to know. But we use this in upper level analytics classes to figure out what to analyze between data sets. Should we be analyzing the averages, or should we be analyzing the medians? So this is 320 notes, really good thing just to kind of see what they're doing and how we're looking at the departures from normality right there. So all to say for this question, and drop one in the chat, Taylor, if you'd like, it follows a straight line. The line is straight, or we should, specifically, the data points follow the straight line, follow a straight relationship. So we have right here a time of 22 minutes. Below there is 16%. How do we know this? If I get a question like this, what do you think the first thing I'm going to do to 22 minutes is? We're doing a little bit of a different solve, trying to teach this a different way. Check out yesterday's videos. If I'm going to think through this in my head, I would turn 22 minutes, which is the observation, into a what? I would turn 22 minutes, which is the observation, into a what? Oh, good. We'll do it here next, Taylor. So thank you very much. I would turn 22 minutes into a what? I'm writing the notation for mean, standard deviation, and observation. I would start immediately by taking 22 minutes. Are we going to do... We probably won't. We could try maybe towards the end, because we're going to start chapter 6 today. So maybe we might do a question. Maybe we'll do a question. We could start with that. Kind of showing how to do it. What am I turning this value into right now? What have I turned that into? What is this? -1 is a what? Z-score, yep. So the answer is 16% because I've done a lot of these, and I know if the Z-score is -1, well, between -1 and 1 is 68%. So if we have between -1 and 1, 68%, well, then outside total is 32. 32 divided by 1/2 is 16%. And that's what we were looking for. And the mean was at 25, which is a Z-score of 0. And this is below 22. So there's the Z-score, there's the observations, and there's 16%. But the more you do these, the better you get at them. So try it out. Jerry got a 69. We're just going to turn that into a Z-score. So once again, this is the formula. Let's write down so people can see. Observation minus mean over standard deviation. So we'd take right here the observed value, which is y, the mean, which is mu, and the standard deviation, which is sigma. So we'd go observation minus mean over standard deviation equals to 69 minus 70 over 6. Whoops. I was like, well, can't erase there. And that is equal to -0.17. We double check our work. That's what a sixth is. So -0.17. Double check your work, never hurts. 60 minus 70 divided by 6. There it is right there. Round it to 2 decimals. This one, please check out yesterday's videos. You know what I'm actually going to do? Because we have 16 minutes and I don't check out yesterday's videos. Did I type it correctly, Sloan? So if you're seeing this, I went more in depth on these yesterday. So if you're watching this, check out yesterday's video. You know what we're going to do? We're going to drop it here in the chat. But yesterday we went way more in depth and we don't have time to do these problems. I don't want to just enter in the answers here because I do know them and can find them pretty quickly. This one right here. Actually, I've got that one memorized. That one you'd have to do a little bit of math to solve, but we don't want to just enter in the answers. We want to solve for them. So here's past live stream, the 14th. Check out yesterday's office hours. And then we're going to do the other problem here where we went over Canvas content right here. Content number. And we did those problems and drew them out. So you can see the drawings, and we're going to drop the timestamp right here into the lecture. And hey, Jesse, good to see you. Canvas content 3. Once again, trying to work these out. It's not about finding the answers. It's about knowing how to solve them. It's not about just getting them right. It's could you solve a different version of them, which is what I want you to work towards, not just getting an answer right. So think about it as I have to understand how we're solving it, not get it right, which is the tougher part. So we should have 6 out of 10. And there we go. No, but we'll do better. Okay, so let's go do Taylor's question right here. Okay, Taylor says 53 men competed in the downhill skiing event. Let's go check this one out using the normal curve. Okay, the last question of the day, I think. Chapter 5, quiz part 2. Okay. Let's go grab it. Okay, where is it? Chapter 5, quiz part 2. Here we go. Let's go do it. Okay, so what do we have? We're given their times right here. So these are the times that they had. And then it says, what if it's normally distributed? Well, with this right here, first question asks, says the mean is this with a standard deviation of this. If it's normally distributed, what percent of times will be greater than this right here? What do you think we're going to do to this observation first? Let's take the data. And what do you think we're going to do to it? So we have the observation. We have the standard deviation. And we have the mean. So what do you think we will do to this data? To that observation right there, we will do what to it? What will we do to the observation of 108.39? To give it sort of the same sort of context no matter what to know how unusual it is. How unusual is that? How would we standardize something? We can turn it into a what? Anytime you have an observation, you can turn it into a what? What could we do to that? We can turn it into a z-score. So let's go here, observation minus mean over standard deviation. And so the observation is 108.39 minus 103.90 divided by 2.65. And those are just the numbers given to us. Oops, wrong. We're in R right there. I'm going to go over here to this. Let's restart it. Boop. And now we go 108.39 minus 103. I'm going to restart. I might have misclicked sometime. 108.39 minus 103.90. And now we divide by 2.65. Now it's a z-score of 1.69433. Now here's the problem you run into. The problem you run into is that's not a perfect number on the standard normal curve. So the z-scores are for things on the standard normal curve. And I've pinned the app right here that we've been using. We're going to replace the pin message. So Mubot just put it in the chat right here. We're going to open this in a new tab and bring the app over here. Now, if you notice on the curve, it says z-score. And it wants to know, according to the normal, it says, if the normal is appropriate, what percent of times will be greater than this? Well, we could enter in the data as it is, or we can enter in the z-score we just found. There's the z-score. And let's put in, find the p-value, the percent based on a z-score, and then go to the percent above, and how many decimals does it want rounded? It wanted rounded here to, it wants a percent rounded to 1 decimal. So we'd actually need to include another decimal, and it's 4.5, and it does the rounding for you. Once again, this is a proportion. We want to get a percent. So what we're seeing right here is the z-score we calculated. There's all the decimals. But what's really great about this is we could just do it via the numbers it gives, which is the mean of 103.9. I'm going to put it over here so I can see it, and I'll show it to you in a second again. So the mean was 103.90. The standard deviation was 2.65. The observation was 108.39. If you notice, we get the same exact answer. And this is what we've been doing all along when we've been drawing out the curve right here and putting the numbers below it. So we could write it with z-scores, or we could write it with the observation of the test scores, or the observation, as we did right here, of the ski times. This is the observed ski times right here with the mean of 103.9 and the standard deviation of 2.65, and the observed value of the ski time of 108.39 with the percent shaded above it. Make sure you've clicked this right here. But we could have done it with z-scores. And once again, just to repeat, this is the same answer because it's like we're drawing the same curves right here where we were doing it earlier for other questions. Now, the reason we can't estimate this easily is because it lands on a z-score that is not on 1, 2, or 3. And so we have to use an applet like this where we can do the area above. So the answer is going to be 4.5%. So you'll have to use the applet right there, especially for Chapter 5, Part 2. What is the actual percent? So this is looking at the actual data right here, and it was 108.39. So remember, there's 53 ski times. With there being 53 ski times, well, we can take the amount above out of 53. So the amount above was 108.39, was it? So right here, there are 5 above. So there are 5 above. That's a little bit higher. That's 5 out of 53. So that's 9.4. And it's 108.39, right? Yes. So there's the answer, 9.4. Why do these two percentages not agree? Well, if you take a look at the data, and this is what they want to get at right here, we're going to copy it. I don't think this is required, so I'm doing it a little bit quickly. The answer is going to be pretty clear that the data is not normal. The data is right skewed. So you can see the right skew, the mean is higher than the median. So remember, it said if the normal is appropriate, what should it be? Well, the data is not normal, so we can't use the empirical rule. That's the point of the question. So the data is not unimodal and symmetric. It is unimodal. Maybe let's double check. The standard deviation, no, doesn't matter. The distribution is not uniform. No, we want to be unimodal and symmetric. The finisher disagree. No, we didn't make an error calculation. it might be, if you don't graph it, it might be hard to see what the answers are, but you can kind of eliminate. Think about this. This would say there's a lot up here around 110. So do we see a lot around 110 or a lot around 102? There's a lot of observations around 102. Does that make sense? There's a kind of peak of the data around 103, 102. Look at all the observations. So that's where the concentration of data is, around 102, 103. And then there's a 115, or 111, 112 up here, and very few observations. With the peak, the uniforms ruled out. This is centered at 106. Really, you can just look and see where the peak of the data is, where the concentration of 102, 102, 102, 102, 102, 103, 103, 103, and then it starts to tail out here at the end, which would indicate to us the following relationship where there's a right skew to it. And we could also do the graphing in R or JMP. Not required, though, to do this. Moreover, probably looking at the data is better. What can be seen for the histogram? It's definitely right skew. Once again, right to the high, left to the low, whatever way the tail goes, and this is pulled to the high side, so it has high outliers. And we're going to have to take the screenshot of this right here. And it looks a little different because of the bin widths. But Taylor, how'd you do? Does this make more sense? Let me know if you have any questions, but this is definitely a right skewed distribution, and that's why the normal model is not applicable. As long as we've clicked everything correctly, we do get that 100. But a little challenging of a question. Yes, great job, Jesse, right there. It's right skewed. You got it. Got through some points for that. And just knowing how to use the applet is probably the big part right here that might cause people some confusion by entering in the values. Once again, if you find the z-score, you need to put it to a curve with a mean of 0 and a standard deviation of 1. Or you could do where you input the actual values right here and input the actual ski time and find the percent of times higher than your observed x right there. And that's where it'd be right there. So with that, that's got it. Well, we're going to head out. We'll be back here for class in just a little bit. Until then, bye for now, everyone. Bye.